Okay, so pest management to food company standards. So I'm going to be talking about how we carry out pest management to the standards required by the food industry for them to pass their accreditation with various accreditation bodies. But as Natalie said, Grahame Turner from PestAcuity. You've got my website address and phone number down there. So the agenda for this morning, I'm going to go through a quick introduction about what the standards are, and then talk through some of the straightforward requirements of the various standards, followed by a couple of more complex requirements of pest risk assessments and trending. And then we'll have a quick summary and then the question session at the end. So what I'm not going to do today is go into all the individual requirements required for each individual standard. So we're going to cover them generally. If you want to ask any specific questions at the end, and do so, but I'm hoping that going through them generally will be most useful. So the objective of today then is to help ensure safe food. And for some reason, I've got a noise started outside. Is that bothering anybody? Hopefully not. If it is, then shout. So the objective of the standards is to help ensure safe food. And in terms of pest control, it's not just safe food, but it's preventing contamination as well, because food could still be safe to eat in theory, but be contaminated. So in terms of pest control, it's preventing contamination. And the other objective of them is the communication between the pest control company, the food company, and the auditors. Everybody needs to be singing from the same hymn sheet and understanding whose responsibilities are what. So it's a communication objective. And the standards can be obligatory for some food companies. So, for example, if they're serving a particular customer who requires a set standard, then they have to comply with that standard. But for other food companies, it might be voluntary. They might be wanting to demonstrate their standards so that they can attract more customers. So it could be obligatory or voluntary. And note that pest control is just one section of the standard. There's lots of other things covered by them that you don't need to be concerned about. You're just concerned about the small pest control section. And the other thing to note is that there are 1,000 certificated sites across the country. So, and across the globe. I know we've got a lot of international listeners as well. Some of the standards are used globally. There are thousands of certificated sites. So if you want to work in the food industry, then you need to be up to speed with the standards. Examples of the standards, you've got the British Retail Consortium Global Standards, and these, as the name suggests, are used globally. It started in Britain, the idea being to eliminate the need for lots of different standards by different end users, different supermarkets and the like. And quite a few companies have adopted these as the standard that they specify. You've also got SALSA, which is a safe and local supplier approval system. That's more for sort of smaller companies supplying food on a local basis. You've got the AIB, the American Institute of Bakers. This started in America, obviously, and that is used globally to a certain extent as well. You've got the Universal Feed Assurance Scheme, which is more for animal feeds than human feeds. The Soil Association, which is an organic standard for people producing organic food. And then you've got various supermarkets there that have their own standards. Now, it might be that one food company has to comply with more than one of these standards for their customer to be satisfied. So, or their various customers to be satisfied. Okay. One thing when working with the standards, make sure you're working with the latest version. So you have things like the BRC one on the left there is currently on issue 8. SALSA is currently on issue 5, and the Soil Association on revision 17.6. Most of the standards you can download from the internet. So these three are certainly all available on the internet. The individual supermarket ones, then you'll need to ask your customers for. So let's look through some of the straightforward requirements. Clearly defined scope is a key thing. Who is, the scope needs to say who is responsible for what. So the pest controller requirements, what they're down to be doing, and what the client responsibilities are. So the client needs to have a nominated person responsible for pest control, and that needs to be listed in this clearly defined scope. It also needs to cover the species that are covered by the contract, the methods. So there might be some restrictions in the methods. For example, with the Soil Association one, they'll want specific organic requirements. You can't use certain pesticides in certain parts of the site. And that can be the same with all the standards. And then you have put down things like your call-out procedure, how long before you get to site when you've had a call-out. So there needs to be a scope. In addition, there needs to be a schedule of routine or PPM visits. Now, the manufacturing industry tends to know what PPM means, planned preventive maintenance. I like to use it as proactive pest management. So that works well in terms of routine visits, to call them PPM, because people understand that. And it might be that you're doing these 8 times a year or 12 times a year or 24 or 52, whatever. There needs to be a schedule of dates written down so everybody knows when you're going on to that site. Then you need to have a location plan that needs to show the monitors, where those are located, any proactive controls, and it needs to be reviewed on at least an annual basis, or unless there are any changes to the site. Your technicians working on those food company sites need to be qualified, and the minimum standard is the RSPH level 2 generally for most of the standards. For the technicians, there is a requirement in one of the standards for the field biologist to be qualified to RSPH level 3, but there aren't that many RSPH level 3 qualified field biologists around the country. Most companies will accept the field biologist as being the equivalent qualification. So the field biologist is the key one to have. Monitors or control points might be restricted to a certain extent. For example, box design. There's one standard that specifies that the trap boxes you use have an indicator on them when a trap's gone off. So if you look at the box at the top there, the top picture, it shows a slot in the top of the box. If you can see the yellow mark there, you know that you can tell whether the trap's gone off or not. That particular box is blue for the food industry use and also metal detectable. So that might be required by some customers. There can be restrictions on toxic baits and where they're used. There might be non-allergenic. For example, I went to one site where I was doing a field biologist visit, and as I read the instructions on the entrance to the site, it said the site was gluten-free. And I went around the site and found that every bait contained wheat. And so we had to do a quick change of the bait to make sure it was non-allergenic. And there are non-allergenic ones available. The boxes generally need to be secured in place. So they'll be put in place with bits of wire to secure them so they can't get dislodged too far. And if any boxes do go missing or become damaged, then it's important to investigate why they've gone missing or damaged. It might be that they've contaminated product, it might be that somebody's stolen them. If they're getting damaged regularly in the same place, then it might be a case of looking for an alternative location. There's one standard now that mentions bird prevention and says specifically there must be measures in place to prevent access to buildings and roosting under canopies by birds. This doesn't mean that every canopy you have has to have a net across underneath it. It just means that you need to do a risk assessment and see if there's potential for birds going in there or if they're likely to. So if you've never had a bird infestation there in the past and there aren't that many ledges there, then you might decide, look, it's not appropriate to put a net across this one. But if there's been a history, then it might be appropriate to do so. Treatment reports are an important part of the process as well. These need to be comprehensive, so they must say everything you've done. Don't leave any parts out that you've done because it might be needed for due diligence purposes or anything at a later date. But they also need to be concise, so don't waffle in them. Keep them as clear and short as possible, but covering everything. Some reports might have photos in. I do think it certainly helps, as people say, a picture tells 1,000 words. You can see from those two pictures on the right there, the top photograph shows some Mediterranean flower moth pupae mixed in with frass and webbing and residues taken out from a bit of baking machinery. And that, just showing that to the customer, does tell a big story. Or even the load of German cockroaches, like you can see on the trap on the bottom there. That does help the customer understand problems. Obviously, the treatment reports need to include customer recommendations as well. And if there are any small recommendations that the technician can do when he goes around or she goes around with one or two proofing or housekeeping recommendations, then the field biologist goes around and lists all the recommendations. And these must be reviewed or signed off by the customer. So there is a requirement for them to be participating in the process. Infestation elimination. If there is an infestation, then there must be an eradication plan to eliminate it, and that must be eliminate them promptly. So it's a case of drawing up a plan. You get an infestation, you decide how you're going to control it, you communicate that to the customer. And if for some reason it's not controlled within your expected timescale, then it needs to be escalated up to somebody more senior in the pest control company and in the customer's company. You need to identify root cause. Okay, so you're set in place your eradication plan, but you're also looking for root cause, because then if you get rid of that, you can prevent recurrence. So get rid of the root cause as well. John Horsley is going to be talking about root cause later. There needs to be an in-depth survey by the field biologist. The minimum tends to be 1 per annum, but it might be that there are more required depending on the pest risk assessment. And this is a report on the quality of the technician's work, and it identifies hidden issues. So there are some parts of the site that the technician might not get to on a regular basis. Ideally, the field biologist visit will be carried out when machines are shut down, so he can have a feel around inside machines and look around in hidden crevices while the machines are stopped to see if there's anything hidden. So, for example, if you look at the picture that looks like to be just a splodge on the right there, if you look closely, you can see 4 mites crawling around in that dust and debris. So the field biologist would be expected to pick up those sort of things. And as I said, the field biologist needs to include a full list of customer recommendations to make sure everything is being done to prevent pests on the site. And another general one is staff awareness training. And the customer will need to be trained in key pests that might infest their site, the problems caused by these pests, any how to look for evidence and identify evidence of the pests, and what to do about it. So the operative staff might need to know those 4 sections, a little bit about the pests, but the key thing, what they've got to look for and what they've got to do with, in terms of who they need to report it to help get it resolved. And in terms of the management on site, they will also want to know a bit about the prevention requirements that they need to be responsible for. Okay, so those are the general requirements, or more easy to understand ones. But there's also recently crept in the requirement to do pest risk assessments. So what are these about? Well, in the olden days, you used to just have a standard 824 visits per annum, 8 technician visits, 2 field biologist visits, and 4 EFK services in a year. That's no longer considered appropriate. Nowadays, monitoring control is more based on individual site circumstances and requirements. So a pest risk assessment needs to be carried out, typically by the field biologist, and then you can come up with a joint agreement or a partnership where the FB role is to make that carefully considered judgment as to how many visits they need for each aspect of the control, and the client role is to have confidence in the field biologist, working sometimes through the key account manager. And these risk assessments, there's a requirement to do them annually, plus again, if circumstances change, which might be a change in the facility or a change in the pest status of the site. There are 2 stages to them. First of all, collect the data on the site's vulnerabilities. And for that, you can read hazards as in a risk assessment. And you need to look at surroundings, buildings and structures, the ingredients and products, used on the site and produced, the site operations, and the infestation history. So collect data on all the vulnerabilities and then assess the risk. So let's go into that in a little bit more detail. Look at the surroundings, check the proximity to railways, waterways, landfill, farmland, woods, etc. And there are sources of pests that come from all of those places. You might have rats coming in from railways or waterways or landfill, your flies coming in from landfill, etc. Farmland can be a similar source. Neighbours, if you've got attached buildings like you might have in the middle of the city, then buildings can run through them. You might get cockroaches or mice running through from one building to the other. So if they're attached buildings, that has its own inherent risks. There might be poor controls on a neighbouring site. So even if it's a detached site, it might not be a food company, and there might be all sorts of debris around that provides harbourage for them. They might have poor waste control. They might have overgrown vegetation that makes the rats and other pests a lot more comfortable. So bear in mind the neighbours. Obviously, if there are poor controls there, then go around and knock on the door, see if you can do their pest control for them and improve the situation. But that might not always be possible. Look at the grounds. Is there debris in the grounds? Is there overgrowth? What's the waste management like? And the landscaping like of your customer? So, for example, if we look at the right-hand picture there, you can see there's vegetation that runs right up to the wall of the building, and indeed up the wall of the building. So rats will happily cross that and go up into the building, explore ways to find their way in. But in the left-hand photo showing the band of gravel and the like there, then that's a bit exposed for them. They wouldn't like to cross there. They'd be a bit reluctant to cross it unless they're desperate for food. And they couldn't burrow into the gravel either. So they're less likely to infest that sort of place. Look at the buildings and the structures. Old buildings, obviously more susceptible to pests. Look at the state of proofing. If there are holes all over the building, then you're going to get more pest problems. The management of the proofing can make a difference. So if the customer attends to any proofing you recommend without any delay, then that's going to mean less of an issue. The construction of the building, if it's made with lots of voids and cavities and the like, then that's more risky. The materials it's built from, if it's made from steel, it's obviously going to be less penetrable than something made with lots of timber in it. Look at the services. So, for example, the top photograph there shows the grating above a trough where the main power cables goes from the plant room into a building, and that can get infested by rats. So the bottom photograph is taken underneath that grating, and you can see there, the smear mark going up onto the ledge. You can see some scratch marks on the claws on the left, and you can see bits of gravel that have been scooped out from inside. So that's become a rat harbourage, and that grating itself. So you need to bear those sort of things in mind. Any unused parts of the building, there might be some parts blanked off. Well, that again increases the risk. Look at the ingredients and the products manufactured and used on site. Think where the supply of products has come from. Has it come from accredited suppliers that are accredited to the same standard? Has it come in from overseas? What is the risk from their material coming into the site? Look at the attractiveness to pests. So again, the photograph here shows food at a animal feed mill. So you've got a lot of spillage and the like there, but that food is very attractive to pests. So you've got a higher likelihood of infestation there. Look at the equipment produced on site. Are there lots of nooks and crannies in it? Any dead spaces in there where residues can build up? Processing temperatures can affect it. So if you've got hotter machinery, hotter equipment, then insects and the like particularly are going to breed up far more quickly, and it's going to be more attractive to pests. Look at the turnover of raw materials. If a pallet sits there for a long time while they just use a small bit at a time, then that's going to be more susceptible to infestation. Packaging of the product. Some packaging is is safe against infestation, so tins, for example, but a lot of other pests can chew their way through paper and polythene and foil, depending on the nature of the pest. The food safety risk of finished products can make a difference. So if you've got tin products, it's going to be less risky. But if you've got high risk food, such as sandwiches or whatever, that are not going to be cooked again before they're consumed by the end user, then that's a bigger risk. The site operations can affect it. Are there good incoming goods inspections? Is housekeeping done well? Look at the deep cleaning schedules. So photograph on the right there shows some pretty poor cleaning, really. They've done the easy bits, but left the other more awkward bits. And that's not good enough for good pest prevention. So that would mean a higher risk. Look at stock management. Do they have good first in, first out stock rotation? Look at seasonal variations. So don't just look at it necessarily at one point in time. If the products that are manufactured throughout the year vary, or processes vary, then that needs to be taken into account. Operational periods, whether the factory is open at night will make a difference. And the level of site support, so how good the customer is at doing the actions you recommend. Look at the infestation history of the site. Have there been rodents, public health insects, birds there in the past? What has been the frequency of infestation, the duration of the infestation? How long ago did it happen? And what was the impact on the product or the business? So take all those into account as to whether there's likely to be an infestation again. So once you've got all that information, all your details on the vulnerabilities, then you need to decide how to assess the risk. And the way I do this that works for me is to do a decision tree. And I split into absolute requirements and subjective vulnerabilities. So if we look at this little table here, there might be, say for example, we're looking at the number of field biologist visits per annum. The absolute minimum required by one of the standards, for example, would be 1 per year. So we know that's the minimum we've got to work to. But it might be that if you've got 2 more subjective vulnerabilities, then you recommend they go up to 2 visits a year. If they've got 4 more subjective vulnerabilities, then perhaps they go up to 4 visits a year. So, you can adjust it that way. And the same with, say, the number of visits for rat monitoring. There might not be any absolute ones there, so all subjective, but you might have a lot more subjective vulnerabilities. So you decide how many of those are appropriate to mean a certain number of visits per year, which might take you up to, 52 visits a year, weekly visits if you've got a really vulnerable site. So that's a bit about pest risk assessments. Let's move on to trending. What do you mean by trending? Well, this is where we look at information that we picked up from infestations, what pests have been found on site, and we look at it to assess what we can do to prevent it happening again. So, but if we look at trends rather than just a spot in time, that can give us a better picture. So we do it for the standards, it needs to be done at least annually. But sometimes it's useful to do it more frequently than that. And in terms of how we do it, it's a case of different for every different aspect that you want to look at. So there's lots of different ways you can look at it. Let's look at a couple. So for example, we might look at total electric fly killer fly counts in the production area. Now, obviously, this is just one way of looking at it. You might be looking instead at the fly counts in each individual EFK in the production area. You might be looking at the individual species caught in each individual fly killer in the production area. Or you might be looking at the whole site, not just production area, but goods inwards and whatever else as well. But just for the purposes of this graph, we'll just look at total EFK fly counts in production. And we've got 1 year's worth there, March, June, and September. You can see the counts there. You need to set a tolerance level so that you know what is excessive. And you need to discuss that with the customer to make sure that you're all in agreement as to what the tolerance level is. With the likes of rats and mice, obviously the tolerance level is going to be 0.
But with flies, there will always be some getting into a building, so you need to have a tolerance level that that balances that. And we might say in this occasion that on these counts we've gone over the tolerance level, so we need to do something to help reduce it. And you might, for example, recommend better door control in the warehouse. So you implement better door management there, and then you look at it again, and you can see that the counts have gone down the following year, but they're still excessive. They still exceed that tolerance level. So what else can you do to help get them down further? Well, perhaps you could install an additional EFK in the goods in and see what the counts are after that. Now, ideally, you won't be taking 3 years to reduce your fly counts. You'd look at everything holistically, but this is just to show what might be happening. You might, after you've made some improvements, still find problems and think what else you could do. So the third year, we've come down to an acceptable level. So we're happy with that. But you could look at it in a different way. So if we look back at year 2 to see the species that were caught, or the groups, the categories as opposed to species. So year 2, we've got 500 large flies, 500 small flies, 100 night flyers. I tend to split them into these groups. Large flies typically mean something coming in from outside, and that can include anything from the lesser house fly up to crane flies, that sort of thing. I have seen some strange categories with some pest control companies in putting things like crane flies and lace rings together. And that doesn't make sense because they come in at different times of day. They're different creatures. So large flies, anything bigger than a lesser house fly goes into that group. Small flies, these are the ones less than 5 mil. These are the ones like your forward flies, your cearid flies, your drain flies, fruit flies. These might be breeding inside the building in debris and drain issues inside the building. And that's why I've grouped those into that category. And then night flyers tends to be your noctuid moths, your night flying moths, and your lace wings. So that can help indicate doors being left open at night. And obviously wasps, SBI, and others for various reasons. So we look at year 2, we've got 500 large flies, 500 small flies. We move on to year 3, having implemented the EFK and the goods in, and you can see those large flies have gone right down, gone down to 50. So that's had a good impact in catching the flies before they get through to the production area. And you've got 600 small flies, so they've gone up a little bit. We can now look at, focus on getting rid of those. And obviously the doors are still being left open a bit at night, so we need to work on those as well. Now, tolerance levels for different fly killers might be different. So, for example, you've got a higher tolerance level at goods in than you have in the production area. So you need to look at individual fly killers or individual areas to decide what the tolerance level is in those different areas. Let's look at another type of graph. So warehouse moth pot counts. If you've got moths being a potential problem on site, you've got one line there from one moth pot A that's climbing up steadily over time. That can help indicate the problem in that part of the warehouse or wherever these are located. There might be an old pallet that's been sitting there, no longer used, don't use that ingredient anymore, and it's sitting festering. Well, this could be an indication that there's problems happening there, and the orange one be the next nearest trap. So that can help indicate problems, and you want to be following this closely and seeing any increases to get it rectified. This is a graph that the food company wouldn't be particularly impressed with before you started the contract, but great for you once you start a contract if you get something like this. So you've got infestation of all sorts of pests before you start. Within a short period of time, you get them all down to 0, and over long term, you keep them down to 0. That would be great to be able to demonstrate that to your customer, wouldn't it? So in summary, compliance with the standards requires a keen and dedicated technician. It requires skilled and thoughtful field biologists, and that is a pivotal role for the site. It requires assessment of hazards and risks to decide what's required for the site. Proactive pest management, so don't just react to situations, be proactive. Analysis and interpretation of data. Good communication between the customers, the auditors, and the pest control company, and good documentation. And if you've got all that, you're dancing.
For further information, you can look at the standards themselves. And as I say, some of those are available straight on the internet. And there are interpretation guidelines with the likes of the BRC one as well. There's BPCA training. So, for example, so you want to be a field biologist training course that's very good that the BPCA supplies. I say it's very good, but I don't do it myself. There's myself, PestAcuity, in that I can do field biologist inspections for you, bespoke field biologist training, and field biologist mentoring. And that is everything. So if you'd like to keep the questions flowing, let's see if we can answer some of those.
Great, fantastic. Thank you, Grahame. Can you see me? Can you stop sharing your screen and then I can get some questions up for you? That would be great. Fabulous. Yeah. There we go. I can see us both now. Great. Fab, we've got a couple of questions in there. So it's quite a long one in here, but I'll go to the first bit of it. And the question really was about getting hold of standards, talking to customers and saying, they've got BRC or M&S, they don't always share the standard with their pest contractor, and they do find that difficult. You've got any recommendations how to help with that?
It can be a bit of a pain, but certainly in terms of BRC, that's readily available on the internet. So no problems with BRC, no problems with the likes of SALSA and the Soil Association and UFAS, the sort of general standards. It tends to be the individual supermarkets where it's more difficult to get hold of them. But yeah, your customer is working to that standard. They need to give you a copy of the standard so that you can work through it along with them. So yeah, ask your customer.
Yeah, that's it. Yeah, there's copies to mention in there about whether BPCA can get hold of them and share them. But standards generally, in terms of us purchasing one and then share it with the wider community, that's not something that we can do. And I don't think a lot of these standards would be too happy with that either. But yeah, if you speak to your customer, even if it's just the section that covers pest management, that's what you need, isn't it? So, just sharing that information is what should be asked for, and it should be, given really.
Yeah, I did go into a lot of discussion with M&S a couple of years ago now to try and get hold of a standard for myself, and they said no, you have to go to your customer and work with them on it. Yeah, they would not give me a copy of the standard.
Yeah. Okay, great. Well, hopefully that's helped out. It's an anonymous question, but hopefully that's answered that there. So from Hans here, could you share, Grahame, how external lighting at loading docks and exit doors could impact night fly populations? What type is better? Yellow, mercury, white lamps, LED, things like that. As low a light as possible, obviously. Moths in particular are heavily attracted to all forms of lighting. In terms of which works best, I haven't looked into it. I haven't done any comparisons, but the key thing is lowest light and most directional that you can work with is going to be the best. Great. But yeah, it's something that's probably something to do a bit of research on and see what we can come up with. Yeah, how does the external lighting at things like loading docks, how does that impact night flyer populations? Just is there a bit more?
It definitely does. Definitely does attract them. Obviously, the way night flying moths work is they orientate themselves to the moon, and these lights outside, moon replacements, as it were, and so that will attract them heavily. Yeah, that's the way you trap moths to do research on them is to use a light trap. So.
Great, good stuff. One more question here from Dean. So EFK analysis, what is your take on the count within the catch tray of the species?
What's my take on the count? Not quite sure what that means, but I've categorized them, as I said, into large flies and small flies. They are quite difficult to identify, especially if you're a technician and not done in-depth studying of insects. Then it's difficult to identify the different species of large flies. So, for example, some people will split into blowflies and house flies and have those separated out because they say, well, a blowfly might have arisen from an infestation of where you've got rodents or pigeon bodies decomposing. You might get blowflies internally. but your average technician will struggle to identify the difference between, blowflies and houseflies even sometimes, because they're caught at awkward angles. They've got a bit dusty because they've been there a few weeks. So that's why it's a lot easier just to say, typically larger flies will come from outside, because on average they will have done, and smaller flies from inside. So, but the other aspect they might be talking about is counts. And yeah, you have to estimate to a certain extent. That's where it's good to have sticky boards as opposed to catch trays, because with a sticky board you can count one or two of the average looking grids, average looking squares, and then multiply it up. So you can give a good count that way. But hopefully in a production areas you're going to have very few, and you've got a higher tolerance, as I say, in the goods in area, and probably something in between in a room that's one door away from the production area where you've got uncovered foods.
Great. Yeah, you interpreted that question absolutely perfectly. Dean's just said, yeah, he meant ID and numbers. So that was a good answer. Thanks, Grahame. A couple more coming. So good morning, Grahame. What would your suggestion be for preventing any pest issues, i.e. rodents and insects entering an open-fronted warehouse? And that's from Anthony. So it's a big question.
I wouldn't recommend an open-fronted warehouse, really. You really do have to try and keep the warehouse shut. It's not appropriate, really, to have a food industry that's or food company that's accredited to a food company standard and have an open-fronted warehouse. It does need to be kept closed as much as possible. So. But if I'm looking at that literally and saying, what would my recommendation be? It would be the guys on site every day would have to be well trained and be looking on top of things, and you'd have to have regular visits. But do your pest risk assessment. Just look at what history's been on the site. Look at whether there are any cavities, voids there that they can go into and nest. How quick the turnaround is of stuff. But it does have to be pest risk assessment based, and try and avoid wall-less sites wherever you can, open warehouses wherever you can. Keep those doors closed. Keep keep it secure.
Like you say, if that's the case, they're going to need someone there on regular occasions to keep an eye on things. If that's the case, but have you ever experienced any accreditations that would be happy with that? I mean, surely not. Having an open fronted.
Not in my experience, but
No.
If somebody can justify needing an open warehouse, then that's a possibility. So it might be temporary storage outside or something, and in an open warehouse until they move it inside. Well, if you just put much more rigorous inspections as you go into the secure part of the building, then that could be appropriate.
Great. Yeah, good stuff. We've got another question. We're on time now, but we've got another question. Let's do it, Grahame. Everyone's enjoying your answers. So if you've got another minute or two. Ben here says, how do you work out tolerance levels on a food production line, for example? Are there any rough figures on what would be an acceptable figure?
No, there aren't any guidelines that I'm aware of. I work it out with the customer as to the risk to that individual product. So it does very much depend on the product. And very much, depends on who they're selling it to, what standard they're working to, and the risks from the different animals that might infest. So you've got to treat every site differently. That's the theory behind the pest risk assessment. Is as you decide what's appropriate for that site, those products, and you work with the customer to find out what their acceptance is. And between you agree a tolerance that can change over time. Doesn't have to be a set tolerance forever, but you work out a tolerance, decide what is appropriate, and then you monitor it based on that for a period of time. And as I say, the tolerances can vary. If you're looking at electric fly killers, you can have different tolerances for each individual fly killer. But that can get a bit complicated. So I tend to generalize into 3 groups. And that makes it a lot easier for doing the analysis.
Great, good stuff. Anthony here, who asked that previous question, said, thank you, Grahame. And in terms of the open fronted, he just made a comment saying he's in Scotland, I believe, and it was their approach to, or the government in Scotland, their approach to COVID and allowing airflow. So that's why they open fronted. Interesting, yeah. Deal with one problem by creating another. Indeed. Okay. But great, that's fabulous. That's all the questions. We managed to get them all done. So thank you, Grahame. There's been lots of people saying thank you for that, and it was very interesting, and I extend that. So I really appreciate you being with us today.
Thanks, Natalie. Cheerio, everybody.
Take care, Grahame. Bye-bye.